Alright, so we're on lesson 9 of our statistics unit entitled The Mean Absolute Deviation. So we should remember from last week's lesson that deviations are what? Your deviation is your mean minus what? Minus the value. Absolute, well, we have to remember all the way back from the beginning of the year, absolute is like absolute value, where you're just taking the positive number to determine distance. How far away is -3 from 0? Well, it's 3 jumps away. So for example, if I have this, -3, -2, -1, it is 1, 2, 3 jumps away from 0. And then mean, we've been discussing what is mean again. Mean is you add up all numbers and then divide by how many numbers you added. So let's continue with this example number 1. In lesson 8, Marvin tried to decide to which of the two cities he would rather move based on comparing their mean annual temperatures. Since the mean yearly temperature for New York City and San Francisco turned out to be about the same, remember they were 63 and 64, so that is about the same. He decided instead to compare the cities based on their variability in their monthly temperatures from the overall mean. He looked at the two distributions and decided that New York City temperatures were more spread out from their mean than were the San Francisco temperatures from their mean. So let's look at these exercises using that information from yesterday. Exercises 1 to 3. The following temperature distributions for 7 other cities all have a mean temperature of approximately 63 degrees. They do not have the same variability. Consider the following dot plots of the mean yearly temperatures of the 7 cities in degree Fahrenheit. So again, what is their mean temperature? Well, their mean temperature is 63. So all of these have a mean of 63. So before we continue discussing these specific data points, let's think of this question. What does a distribution that has no variability look like? So remember, variability is that spread or the change. What if it has no variability? What would that look like? There's no variability at all. There's no change. There's no spread. Well, it's actually going to look like this. It's just going to look like a vertical line. They're all going to be the same because there's no change. Now, what does it look like if there's a lot of variability? Well, if there's a lot of variability, that means there's a lot of change or a lot of spread. So that means you're going to have a lot of dots scattered about. All right, so let's continue. We're going to refer back to those 7 charts, or 7 dot plots. Which distribution has the smallest variability of the temperatures from its mean of 63 degrees? Explain your answer. So we're looking for the one that has the smallest variability. Well, which one has the least amount of change? Well, if I highlight all their change, this is 1. Here's some change. Change. Going from the smallest to the largest. Which yellow line looks like it is the smallest? Well, my smallest is this one right here, which happens to be City A. How do I know it has the least amount of variability? Well, it's because all the points are the same. There's no change in it. So that's what I'm going to type in for this answer. City A, because all of the points are the same. There is no change or variability. So that means it's the same temperature that whole entire year. Okay, now let's look at this second question. Which distribution or distributions seems to have the most variability of the temperature from 63 degrees? Explain your answer. So now we're looking for which one has the most. And since it said plural, it can be tied as well. So I might have more than one. So let's look again. I'm looking for a long yellow line this time because that means what? That means there's a lot of change going on. So which one has the most variability? Well, I see some possible answers. So I'm looking for that long yellow line. Well, C has a kind of long yellow line, but look at D. D's is much longer than C's. So maybe it's D. Notice E's. E's is also pretty long. And F is also pretty long. If I want to be exact, I can subtract these values to see which one is the longest. Or, since it said I can pick more than one, I'm just going to pick all three of these because they all have a lot of variability. So that's going to be D, E, and F. So which distribution seems to have the most variability? Cities D, E, and F have the most variability. And why? Because their data points are spread out, and I'm going to spell check for spread, are spread out the most. Okay, so now this last one, or the 7 distributions from least variability to most variability, and then explain why you list the distributions in that order. Just since you're on the computer, we're actually going to delete this, so we're just going to look at the variability, ordering it from the least to the most. Well, I'm just going to one more time highlight, and I'm looking for the smallest yellow lines to that largest yellow lines. So number 1, the smallest is A because that's my smallest yellow line. It looks like C's my next smallest, so I'm just going to do a 2 for C. G looks small, so does B. So I'm just going to pick which one I think. 3 is G, 4 is B. I think D, just by looking at it, that looks like it's the largest. So that's going to be my most variability, which is a 7. And then these ones are kind of hard because they look about the same. So I'm just going to say 6 and 5. I can easily tell that this is my smallest, this is my largest, and the rest are just guesstimates. Alright, so what it looks like I'm going to put is what? A, C, G, F, E, and D. Alright, let's go on to our next one. Measuring variability. Okay, based on just looking at those 7 distributions, there are different orderings of variability that seem to make sense. That means the answer that we put up there, putting them from 1 to 7, there are some numbers in the middle, those 2, 3, 4, 5, and 6, that maybe we could have flipped them around because they're all pretty close. So we're going to look at how can we exactly order variability. Aurelia is interested in developing a formula that will give a number that measures the variability in a data distribution. So we're looking for a way to organize that variability in a distribution. She would then use the formula for each data set and order the distributions from lowest to highest. She remembers from a previous lesson, because Aurelia is a genius, that a deviation is found by subtracting the mean from a data point. So remember, I'm subtracting the mean from a data point. The formula from the previous lesson was what? Deviation is data point minus mean. So using deviations to develop a formula measuring variability is a good idea to consider. I'm going to repeat that again and underline it. Using deviations to develop a formula for measuring variability is a good idea to consider. Okay, so we're going to be walking through and figuring out how do we find out this formula. So I want you to think first, do you think Aurelia is correct? Do you think using deviations is a good basis for a formula to measure variability? Well, the answer is yes. A deviation measures how far a data point is from its mean. So a deviation by itself, this is my mean, M for mean, tells me how far it is from the mean. So that is my deviation. That certainly addresses the concept of variability. This deviation is how I can tell the variability, how I can tell its change. When are deviations negative? So think about it. If this mean was 6, I have a point here and a data value here. When is my deviation negative? Well, my deviation is negative whenever it is to the left of the mean. If it is to the left of the mean, it is a negative. When are my deviations positive? Well, my deviations are positive when they are to the right. Notice here it would be my data point is 7 minus the mean, which is 6, so that is 1, which is that positive. My negative would be 5, that's my data point, minus 6, that equals negative 1. And what do you remember when I add up my values for deviations? When I add up my values for deviations, they always equal 0. So I'll always have negatives, I'll always have positives. Okay, let's go on to exercise 4 to 6. The dot plot for the temperatures in city G is shown below. So here's city G. Use the dot plot and the mean temperature of 63 degrees to answer the following questions. Well, what is my mean temperature again? Well, it's 63. It says so right in my text. So I know my average is going to be right about here. Just drawing that balancing point in case I need it. So now I'm going to fill in the following table for my data points. So what I'm going to do is I'm just going to delete some of this to see if we can get it to all fit on here, and it doesn't look like it'll cooperate, so I'm going to have to flip back and forth between these two. Fill in the table. Well, look at this. I don't even need my dot plot. So what I'm going to do is, this is going to be 64. And where did that 64 come from? Well, it came from my table right here. And I can see that temp is also right in here, in this group right here. And now I'm just filling it. Remember, deviation is your data point minus the mean. So my data point is 64. And what am I subtracting? I'm subtracting 63. I'm just going to fill all of these in. 64 minus 63. 64 minus 63. Notice this one. It is now going to be a 68 because my data point is 68. My next one, 68 minus 63. The last one is what? 70, because my data point is 70 minus 63. 63 again is that mean. So now I'm just filling all these in. This would be a positive one. This would be also a positive one. This would also be a positive one. This is going to be a positive 5. A positive 5. A positive 7. So what should my sum be? Well, remember, whenever I'm working with deviations, their sum should always equal 0 because I have a left side and a right side. But just to check, I'm going to use my calculator. You're allowed to use your calculator today. Just going to add all these up. So I have a negative 10. Then I'm taking away 6. Taking away 3. Taking away another 3. So that's all my negative values. So now I'm going to add my positive values. So there's plus 1. Plus 1. Plus 1. Plus 1. And I only added 4 ones. How many are there? 1, 2, 3, 4, 5. So I need to add another plus 1. Now I'm doing a plus 5. Plus 5. Plus 7. And look, it matches what I predicted for it to be 0. So I know my mean is the correct spot of 63 since my deviations all equal 0. Okay, so let's continue. My sum is 0. Why should the sum of your deviations column be 0? So here's my hint. We call the balanced interpretation of the mean of a data set. We already discussed it. So what I'm going to do is I'm going to fill my answer in. the mean is what? The mean is the value that makes the sum positive and negative deviations 0. It is the balance point. So that is the main idea why the deviations are 0. It's because they are that balance point. Okay. Another way to graph the deviations is to write them on a number line. What is the sum of the positive deviations, the deviations to the right of the mean? What is the sum of the deviations to the left? So all I'm doing with this dot plot is instead of plotting numbers or plotting dots, so I see I have a dot here, 70. I have dots at 64. All I'm doing instead is I am just plotting those values. So before, I would put a dot here on 68, dot on 70, dot on 68. Instead of putting dots, I'm just plotting their values. So I want you to think, what is the sum, so sum means add, of the positive deviations? So what do you think the sum of my positive deviations are? And what is the sum of my what? Negative deviations. So what do you think these equal? And then the last question is, what is the total sum? Well, I'm just going to pull out my calculator, since I'm allowed to use a calculator today. And I'm going to add all of my positive deviations. So there's 1, 2, 3, 4, 5, plus 5, 10, plus 7. So I can answer that first one. The positive deviations is a positive 22. Now I'm going to do the same thing but with my negatives. So here I have a negative 10. So I put that negative sign on my calculator. Then I'm taking away 6, taking away 3, taking away another 3. And look at that. My negative deviations equal a negative 22. So what is the sum of my deviations? Well, the sum of my deviations, I add them together. Positive 22 plus a negative 22 is 0. So it's the same thing I just showed in that previous problem. But look what we're going to do to expand on this. We're going to be using this information, plotting the deviations, to find something called the mean absolute deviation. That's going to be assisting us. Alright, now I want you to think of what we just talked about with deviations and distances. If I have this, my mean is 6, I have 5 and 7 as two of my data points. What is their deviation? Well, this is going to be 5 minus 6, so this is a deviation of negative 1. 7 minus 6, that's a deviation of positive 1. Now, what do I do if I'm talking about distances again? Well, remember, distances are what? Distances are always positive. So how do I take this negative and make it a positive? Well, I take its absolute value, and I take its absolute value of a positive 1. So the absolute value of negative 1 is 1. The absolute value of 1 is 1. So now what's going to happen to my sum of the absolute value of deviations? Well, if I take the sum of my absolute values, I'm going to get what? I will get 1 plus 1 equals 2. So if I'm taking the absolute value, because these are distances, if I take the absolute value since they're distances, that's not going to equal that 0 anymore. So I'm going to divide again by my number of deviations. So we're going to walk through an example to see how we do this. But just remember, I'm following this formula. Find the sum of the deviations of their absolute values, and then I divide by my number of deviations. Okay, so let's work through this problem. And let's zoom in a bit. By balancing the interpretation of the mean, the sum of the deviations for any data set will always be 0. Sabina is disappointed that her idea of developing a measure of variability using deviations isn't working. She still likes the concept of using deviations to measure variability, but the problem is that the sum of the positive deviations is canceling out the sum of the negative deviations. What this means is what? My sum of the deviations is canceling the sum of the negatives. That means that when I'm adding my deviations, they're equaling 0. So I've come up with an idea of what we can do so that the deviations do not cancel out each other. So what can I do again to make sure my deviations don't cancel each other out? Well, one suggestion is to take the absolute value of those deviations. So again, I'm just going to fill this chart in. So remember, my deviations, my regular, is the value minus what? Minus the mean. So this is going to be a positive 1. And then the absolute value is a positive 1. I repeat, so this will be 64 minus 63. It's a positive 1. And the absolute value is a positive 1. And I repeat, but now I have one more 64. So it's the same positive and positive 1. Now notice it's changed to 68 because that's my new value right here minus the mean. So now it's positive 5. The absolute value is positive 5. So now I'm going to go to my next one. There's one more 68 value minus the mean, positive 5, positive 5. And my last value is 70 minus 63 is a positive 7, positive 7. So I have my chart filled out. So from the following graph, what is the sum of the absolute deviations? So remember, why is this positive since it's on the left? Well, it is positive because I took what? That absolute value, that absolute deviation. So let's check. What is going to be the sum? I'm going to use my calculator, and I'm just going to add them all up. I have a 10 plus a 6 plus 3 plus 3. Notice how there's 2 3's. Then plus, there's 1, 2, 3, 4, 5 ones. So that's 1, 2, 3, 4, 5 ones. Plus, and there's 1 5, 2 5s. So 5 plus 5 plus 1 7 equals, so what does my sum equal? Well, my sum equals a 44. So now I'm going to keep on going down. So now, Sabina suggests that the mean absolute deviations could be a measure of the variability of the data set. So remember, variability means spread. So we can maybe measure that spread by that absolute deviations. Its value is the average distance that all the data values are from the mean. So please pay attention to this. Its value, so the mean absolute deviation, its value is the average distance that all the data values are from the mean. So it's not just positive, negative, because I'm looking at distance. So it's my average distance, and distance are always positives. It's called the mean absolute deviation, and it's denoted, or it's identified by MAD. Find the MAD for this data set of city G temperatures. Round to the nearest tenth. Okay, so remember from right up here, my previous problem, what did this sum equal? Well, my sum equaled that 44. So that's what it's going to equal, 44. But then what do I have to do? Well, average means what? Means I add them all up, which I did, but then I have to divide. So I have to divide by what? I have to divide by the number that I added. I added 12 deviations. If I go back up here and check, how many data points were there? Well, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's where this 12 comes from. So what do I have? I have 44 divided by 12. So I'm going to use my calculator. 44 divided by 12. And I get 3.66667. However, I note it says round to the nearest tenth. So that will be 3.666. Nearest tenth is right here. So remember, for rounding, I look at the number after it, and I see, is this bigger than 5 or less than? If it's larger, I round up. And it is. So this means I round this up 1. So it is 3.7. So let's write that out so we have it to refer to. 44 divided by 12 equals 3.7. And then just for my units, what is my unit? Well, I'm talking about temperature, so it's going to be 3.77 degrees. That means my average deviation is 3.7 degrees away. Okay, here's my next one. Find the MAD for each of the temperature distributions in all 7 cities and use the values to organize the distributions from least variability to most variability. Remember, so please pay attention to this part. The data for each set has a mean of 63 degrees. Okay? Does the list you made in exercise 2 by just looking at the distributions match this list by ordering those values? So here's our hard part. I'm going to have to match my data and find their means. So I'm going to pull up those means again so we can refer back to them. Okay, just to save us time, we're only going to be doing 2 to 4 of them. We won't be doing all 7. Alright, so let's look here. So I'm going to find what? The MAD. So let's mean absolute deviation. So my first step is, remember, all of these have a mean of what? They all have a mean of 63 degrees. And so now what I need to do is I need to add them all up and divide. So what is my deviations for each of these? Well, for A, since there's no variability, that means all those deviations are 0. They're all right on 63, so there's no deviations at all. So I'm going to be left with 0. The absolute value of zeros will be 0. So that's going to be 0 divided by 12, because there's 12 data points, which is 0. So this was easy since there is no deviations. So its MAD is 0. But now let's look at a more difficult one. Okay, we're going on to B. B, what do I need to do again? Well, I need to add up all of their deviations. Okay, so what I'm going to do first is I'm finding the deviations of each of these. So this looks like it's 54. So I'm going to just list my values, 54, 54, and 54. And I subtract what? I subtract that mean because I'm finding those deviations. I'm only going to do this one time because they'll all have that same answer. 54 minus 63, I'm using my calculator again. Just to check, minus 63, that's that negative 9. So a negative 9. So all of these are negative 9s. There's 3 of them. So that would be negative 9 plus a negative 9 plus a negative 9. Here, this one looks what? This one looks like it's about 58. So this is going to be 58 minus 63. 58 minus 63. And what do I get when I subtract those two? I'm going to use my calculator to check because I'm using that tool. 58 minus 63. And I get that negative 5. There's only one of them, so this one will be easier. Okay, this is 1, 2, 3, 4. This is 64 minus 63. And then what do I get? Well, this one I can do without my calculator, but since I have that tool, I'm just checking. Since I've seen a lot of your math, 64 minus 63, and is that 1? Then I have, this looks like what? This one looks like about 68, so I'm going to put that 68 in. 68 minus 63, that's a 5, and it's a positive. And here I have 1, 2, 3, 4, that looks like a 72. So I'm putting that number in, 72 minus 63. And I'm using that calculator to check. 72 minus 63 equals 9. So now what do I need to do? Well, I found the mean, almost, but I have to find those absolute values and those deviations. So actually when I find the mean absolute deviation, I'm working backwards. I found my deviations, so now I need to find their absolute value. Well, what's the absolute value of 9? Well, it's a positive 9. What's the absolute value of 5? It's a positive 5. So I'm just going to change all of these to positive numbers because I'm finding that absolute deviation. Okay, so now what do I need to do next? Well, I need to find the mean. I found the absolute value, so now I'm finding that mean. So I'm adding all these up. I have a 9. Now let me just put it in a separate color. I have a 9 plus 9 plus 9. So 1, 2, 3 plus a 5. There's that 1 plus there's 1, 2, 3, 4. 1, 2, 3, 4. Then a 5 and a 1, 2, 3. So there's 3 9s. So now I'm going to add them all up because that's what I do for my mean. I add them all up. So I'm doing 9 plus 9 plus 9 plus 5 plus 1, 2, 3, 4 plus, there's this 1 5 plus 3 9s. 1, 2, 3. And I get 68. Am I done with my mean? No, because remember, I also have to divide. So how many numbers did I add? I added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's at 68 divided by 12. 68 divided by 12 will give me, oops, and I know my answer should be much smaller, so I'm just going to check because I think there was an error there. So I'm going to do 68 divided by 12 equals 5.67. So I'm rounding, so 5.7. That means my average temperature is 5.7 degrees away. Okay, we're going to do one more. Since they're so long, we're only doing one more. And we're going to do for E. So I'm going to find the MAD again. My average temperature is what? 63. And so I'm going to look. This looks about what? This looks like it is about 56 degrees. So I'm going to find the deviation, 56 minus 63. I'm going to use my calculator to check. 56, I'm going to clear it first. 56 minus 63 will give me that -7. So all of these right here are -7s. Then I'm going to go over here. This looks like an 84. So I'm going to do 84 minus 63. So I'm going to use my calculator to check. 84 minus 63 gives me that positive 21. So now I find the absolute deviation. And why is that? Well, it's in my name. Found the regular deviation, so now I find the absolute value. The absolute value of -7 is 7. The absolute value of 21 is 21. So all of these are 7 away from my mean. All of these are 21 away from my mean. So now what I do is I add them up. There's 1, 2, 3, 4, 5, 6, 7, 8, 9. So there's 9 sevens. So that means what? 7 plus 7 plus 7, 9 times. Or I can use my multiplication because that's 7 times 9 is 63. And then I can add 21 how many times? 21, 2, 3 times. So I'm adding 21 3 times. I'm just going to check because I think my calculator went a little crazy. So 63, so that's my sevens, plus 21 plus 21 plus 21. And that will give me 126. So when I add them all up, I get 126. Is that my final answer though? No, because my mean, what do I have to do with my mean? I have to divide by the numbers that I added. So I'm dividing by how many numbers that I added. When I divide, I'm using my calculator again. I get 126 divided by 12 equals 10.5. So my MAD equals 10.5. Okay, we're going to go back to our problem. I am just going to write you out all of their MAD values, and then we're going to discuss them. All right? So we had 7 cities. City A had a MAD of 0. City B had a MAD of 5.3. City C was 5.3. City D was the one we did for the very beginning. That was 3.7. City E was 10.5. F was 10.5. And G was 3.7. All right, now let's look at our data. So we have all of these distributions with MAD. What does it mean? Well, this means that for City A, each deviation, each data point was 0 degrees away from the mean. In this one, the average distance away was 5.3 degrees. In here, the average distance was 5.3 degrees as well. And in City D, it was 3.7 degrees. So what we're looking for is your MAD. The higher your MAD is, the greater variability. The lower your MAD is, what do you think? The lower your variability. All right, let's keep going. So now we're on to E. Which of the following is a correct interpretation of the MAD? The monthly temperature in City G are spread 3.7 degrees from the approximate mean of 63 degrees. The monthly temperature in City G are on average 3.7 degrees away from the approximate mean of 63 degrees. Or the third option, the monthly temperature in City G differ from the approximate mean temperature of 63 degrees by 3.7 degrees. Well, let's look at each one individually to see if it works. So City G, its mean temperature is 63 degrees. I'm just going to put that balancing point so remember it is my mean. Are spread 3.7 degrees from the approximate mean. So they're spread 3.7 degrees. That means that the farthest out it can be is what? The farthest out it can be is 3.7 degrees. So that means it would be 60 about to 66. Well, I had data that was much further spread out than that. So it doesn't mean that it's only spread 3.7 degrees away. So it's not this. I had data that was over here and data that was past 66. So let's look at number 2. The monthly temperatures in City G are on average 3.7 degrees from the approximate mean. Well, this one's almost the same, but there's a big difference with this keyword, on average. That just means on average, my positive values for deviations were about at 66, and on average my negative deviations were about 60. Well, that one's correct actually, because I'm looking at the average deviation distance. I'm not saying all my data was between 60 and 66. I'm just saying on average that's how far they were. So if I had some over here, that means I also had some that were a little bit closer. If I had some that were way out here, I had some that were much closer as well. So it just means on average, they were 3.7 degrees away. So my last one, I know this one is correct, but we have to check to see if there's more than one. My last one is the monthly temperatures in City G differ from the approximate mean temperature of 63 degrees by 3.7. Well, that means that differ means subtraction or taking away. So they're away from my mean temperature by 3.7. That means that my monthly temperatures are exactly what? Are exactly 3.7. That means that they'd only be here or only be about here. Is that correct? No, I had lots of data points in G that were much further away. Let's go back and look at G really fast. So here's G. Did I only have data points from 60 to 66? No, I had a lot that were on the outside. I had this guy right here and these two right here. So I know they weren't just 6.3 degrees away. And look at this, I also had ones that were right here and right here. I actually had none that were exactly 3.7 degrees away. All right, here we go. Here's my next one. The dot plot for city A temperature follows. How much variability is there in A's temperature and why? Well, I don't even have to do any math because I'm looking at this keyword, variability. How much variability do I see? Well, I should notice right away that I see 0. And why is that? Well, variability means what? Variability means change. So there is 0 variability. The reason why is because what? Because there is no change or spread in the data. My data is all the same number, so there's no change in it. Okay, does my MAD agree with our answer in part A? Well, yes, my MAD was what? My MAD was 0. And what does that mean? Well, that means on average, what? It means on average, these dots are 0 degrees away from my mean. These dots are all at my mean, so that means there's no change in them. There's no variability. All right, I know it was a hard lesson. This is actually your hardest lesson of the whole entire year. Let's finish up with our lesson summary. My suggestion is that you write our lesson summary down in your notes because you're allowed to use them on your test, and this is going to be most of your test, but it is your choice. So our lesson summary is this. In this lesson, a formula was developed that measures the amount of variability in a data distribution. So I'm measuring the amount of variability. The absolute deviation of a data point is how far away that data point is the mean. My absolute deviation is what? It is always a positive number because that absolute. The mean absolute deviation is computed by finding the mean of the absolute deviations in the distribution. So I'm finding the mean of my absolute deviations. The value of MAD is the average distance that all the data values are from the mean. Please pay attention to this part, your definition of the MAD. The average distance that all the data points are from the mean. A small MAD indicates that the distribution has very little variability, and a large MAD indicates that it has a very large variability. And that large variability means that there's a lot of spread. My suggestion is to memorize these two sentences because this is going to be a question on your test. Small MAD is what? A small MAD is small variability. A large MAD is a large variability. All right, what you're going to do next is your exit ticket. Your exit ticket will be passed out to you, so good luck. Turn your exit ticket in at the end. When you are done, head to Dreambox until the end of the day. All right, good luck.